Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. For this video, I'll be discussing polyatomic ions. So again, polyatomic ions is an important class of ions that you need to know. You need to memorize them. There's probably like 20 of them. There's no way around it. You just have to memorize them. Here's an example of a polyatomic ion. In this case, it's a polyatomic anion, basically a negatively charged polyatomic ion. A polyatomic ion is basically an ion that's composed of two different atoms, at least two different atoms with a charge, that has a charge. So in this case, we have NO3 minus, at least two different atoms, and it has a charge, and that's known as nitrate. You have to memorize it, okay? Know that NO3 minus is nitrate, and know that nitrate is NO3 minus. Get flashcards. Put one thing on one side, put the other thing on the other side. Memorize it. Extremely important, okay? Next thing is this little formula I put right here for you guys. There's one known as the A formula and the B formula. So ionic compounds with polyatomic ions. You need to realize that ionic compounds are basically interactions between positively charged things and negatively charged things. And that's the most broadest and general way of defining what an ionic compound is, okay? So here we have a metal, which is usually going to be the positively charged thing, and then here we have the polyatomic anion, which is a negatively charged thing. You combine the two together, you get an ionic compound. In this case, we have a polyatomic cation, which is a positively charged thing. Then we have the non-metal or polyatomic anion. These guys are going to be a negatively charged thing. Combine the two together, you get an ionic compound. Extremely important to realize that, okay? In regards to naming things, for example, let's look at this one up here, down here, sodium nitrate. If you recall from the previous videos, I talked about how you change the ending of a non-metal to "ide" when you form a ionic compound. In this case, you don't have to do any of that. All you have to do is just say the metal first, okay? So I'll put this here for naming. You just have to put the metal, word, then followed by the polyatomic ion. That's it, okay? That's the whole naming of it. The metal, then the polyatomic ion. So it's going to be the positively charged thing first in regards to naming, followed by the negatively charged thing second, okay? So let's move on to the bottom half of this board, and we'll focus on how to do these problems, okay? So your professor or your teacher, okay, will ask you, hey, why don't you write out the chemical formula for sodium nitrate? You have to know these things, okay? You have to memorize your polyatomic ions. Going with that easy technique I showed you guys last time of balancing charges, that's how we're going to use this time in order to draw the chemical formulas. So starting off with sodium nitrate, what I would do is I'll write sodium plus, because that's the charge it typically has. Nitrate, you have to memorize this, guys. You have to know that nitrate is NO3 minus. The 3 designates that you have 3 oxygens. The negative is the charge. Remember, the superscript, which is the thing up top, is the charge. The thing on the bottom is typically the amount of that specific atom you have. Now if the 3 was on this side in between the N and the oxygen, that 3 belongs to the nitrogen, then it would be that it had 3 nitrogens. So in this case, nitrate is NO3 minus, 3 oxygens with an overall negative 1 charge. So we need to balance the charges. In this case, it's already balanced, so we just write it out as sodium nitrate. There you have it. Nice and simple, okay? No need to make these things complicated. Next one, calcium. You just need to know from the periodic table that calcium is a 2+ or +2 charge. I write it either way. Typically I write it as 2+. And then phosphate is you just have to memorize this, guys. Phosphate is PO4 3 minus, or -3. I just like to write the number first for whatever reason. And then the 4 is referring to the oxygen. We have 4 oxygens. We've got an overall charge of -3. Now what you need to realize is that this is not balanced. We need to balance this out, and we need to find a common factor to multiply this guy by and this guy by in order to have a balanced charge. Now what I would do is I'll multiply this side by 3, and so basically I'll have 3 calciums and 2 phosphates. So if we have 2 phosphates, that's a total charge of -6, right? 2 times -3. Or if we have 2 phosphates, it's is basically that. It's two phosphates, each carrying a -3 charge, which totals a -6 charge. And here we have calcium. Each calcium has a +2 charge. If you have 3 of them, that's a total of 6. So you balance it out by having a +6 and a -6. Now now you guys may be wondering, well, where'd you come up with a 3 or 2? What I like to use, the superscript from one species as the subscript for the other species, and I'll show you what I mean. So for example, let's write it out. It'll be Ca3, right? PO4 parentheses. Okay, you have to have the parentheses because this 2 is referring to the overall species here. It's not referring to phosphorus or oxygen. It's for the whole species. Oops, I'm not putting a 4. I'm going to need to put a 2. 2. Okay, remember, you don't put the charges when you're writing the ionic compound. Again, the 3 is that 3 right there. We're saying there's 3 calcium. Remember, subscripts refer to the amount, so we have 3 calciums. In this case, phosphate, we have 2 phosphates. We put a 2 there, but we can't leave out the parentheses out of this picture, because what will happen is, first of all, it'll look funky. What are you saying? There's 42 oxygen? That doesn't make sense. We're referring to the overall species, the overall negatively charged species. So that's why you have to put parentheses to say that this 2 is referring to the overall species. Okay, now I said earlier that I like to use the superscript of one species as a subscript of the other species. Okay, so the superscript for phosphate is a 3, right? It's superscript is the number up top. The subscript is usually the number on the bottom, so it's the 4 here. Okay, I said that I like to use the superscript of one species as a subscript of the other species. So the 3 here is the superscript of phosphate, and I'm going to use it as a subscript of this species here, and that's what I did here. And I did the same here. I use the superscript of calcium as the subscript of the phosphate, the overall whole species phosphate, not just oxygen but the phosphate, and that's why I put the 2 there. So that's how you could do that. That's the easier technique. Okay, or you could just try to figure out, well, what number do I need to multiply phosphate by in order to get a certain charge here, and what number do I have to multiply calcium by to get a certain charge here, where they can balance each other out. That's one way, or you can do the way I just explained it. You just flip-flop. So you get this number, bring it down there, and get this number, bring it down there. Making sure if you have a polyatomic ion, you have to put parentheses like I did here, because you're referring to the overall species. Now the next one is here. Now we're going from the chemical formula to the name. So your teacher could say that, well, you have this K2SO4. What is that? Write it out for me, okay, in words. Well, you have to recognize that, first of all, K is potassium, and this SO4, you're like, hold on, what is SO4? That's one of your polyatomic ions. You have to memorize that, okay? So in this case, I would say it's potassium sulfate. Okay, sulfate is SO4 2 minus. Okay, so we could try to figure out how they came up with this. So it'll be K plus SO4 2 minus. They did the same technique I did over here. They flip-flop. So they got the 2, brought it down there, and remember this is a 1. They brought it down here. But you don't really even need to put it down there when you make the ionic compound, because it's not going to do anything. I mean, it doesn't make a difference. Okay, it doesn't say anything about the species. Okay, so you can just leave it out. You could omit the 1, so to speak. Okay, so that's what they did here, flip-flopped it. Or you could have done the other way, where you could just multiply this by 2, and you have a +2 and a -2, and they balance each other out. Okay, next one is right here. You have to be able to determine what this is. Okay, you look at this, your teacher says, well, what is this? Li2SO3. Well, you have to realize that Li is lithium, so you need to be able to distinguish that, lithium. And SO3, that's sulfite. You need to be able to distinguish between the two. The reason why I can tell that this is sulfite instead of sulfate is because of that 3. That 3 differentiates. That 4 differentiates the 2 polyatomic ions. So that's how I determined that this is sulfite and that's sulfate. So again, the way they did it was, you have Li plus, you have SO3 2 minus, right? You could have flip-flop where you bring the 2 down here and bring that 1 down there, but you don't really need to bring the 1 here because it doesn't make a difference. But bring the 2 down there to distinguish that you have 2 lithiums. Or you could have said that, well, what charge do I need to balance out that negative 2? Oh, you need 2 lithiums, and that's how they got that Li2SO3. Again, when you make an ionic compound, you don't put the charges in. Now we're moving on to case B, where we have a polyatomic cation with a non-metal or polyatomic anion. Okay, that's the second case we're going to be dealing with. In this case, we have, in this example, we have ammonium carbonate. The only polyatomic cation you need to memorize is ammonium, which typically has NH4+. Okay, you need to memorize that. So in this case, your teacher could say, well, write out the chemical formula for this. I'll do the same technique we've been using. Again, the easy technique. We'll write out the ions first, NH4+. So basically this is saying we have 4 hydrogens and an overall charge of +1. Whenever it's +1, I don't put the 1 there, I just say plus to make my life simple. Carbonate, you just have to memorize these polyatomic ions, guys. Carbonate is CO3 2 minus. You have to memorize it. Combine the 2 together, but first you can't. You have to balance out the charges. Ammonium has a +1, carbonate has a -2. We could do the flip-flop where you bring this number down here and bring this number down here, which is a 1. Or we could just realize that ammonium is a +1, that's a -2. We need 2 ammoniums. 2 ammoniums to balance out the charges, and you'll get this specific. Let me shift this a little bit. I'm running out of space here. CO3 2 minus, right? Then we'll get ammonium carbonate. Now, right when I drew this, an alarm should have gone off like, oh, hold on 1 second, Moballer 12, you made a mistake. That's not correct. What are you trying to say? That there's 42 hydrogen atoms? That's wrong. That should be going off in your head right now. You're absolutely correct. I did that purposely so I could see if you guys caught that. That 2, you need to put a parentheses around the ammonium because, again, that 2 is referring to the overall species. It was referring to the whole ion, the polyatomic ion. So you need to put a parentheses there and put a 2 there. Okay, so NH4 parentheses 2 CO3. Okay, you need to realize that. All right, good. The final one is your teacher will say, well, hey, write out what is the word, spell it out for me. What is this? Okay, you have to realize that NH4 is ammonium. You need to know that. Let me put this arrow a little bit out here so I could have some space to write. You have to realize that NH4 plus is ammonium, and you need to realize that this PO3 is well, phosphite ion is PO3 3 minus, but you need to realize that, hold on 1 second, arm. Actually instead of this 3, let's put a 4 because I want to get this one across. Okay, let's use this ion instead. You should realize that this PO4 3 minus is phosphate, like I had over there. So ammonium phosphate. Sorry about that, guys. I had an itch on my arm. As you can hear, I'm scratching my arm. So ammonium phosphate. So there you have it. Again, how the guys determined this was pretty simple. They looked at ammonium, they wrote it out, NH4 plus, and phosphate is PO4 3 minus. They're like, okay, they could flip-flop where you bring the 3 down here and bring that 1 down there and balance it out like that, or they could just critically think through it and say, well, okay, phosphate has a -3 charge. How many ammoniums do we need to balance out that, considering that ammonium has only a +1 charge? Well, we need 3 ammoniums. And that's how they put the ammonium parentheses 3 phosphate, so ammonium phosphate. So that's 3 long-winded parts on ionic compounds. I'm a little bit exhausted from doing this, as you can imagine. So stay tuned. I think this will be the 4th and final part, where I'll be discussing transition metal elements and the whole naming ordeal with them. And then in a very short little section of that fourth part, I'll discuss what do you guys call it, molecular compounds, and then I'll just throw a bunch of examples where you guys can try attempting to do them. Okay, so thank you guys for watching, and stay tuned to the fourth and hopefully, I'm praying, final part to this series on ionic and molecular compounds.